Have you ever asked a question about your company's internal information to ChatGPT or Claude? If you ask it, it will not be able to give that answer. Yeah, that is the limitation of ChatGPT or Claude. Let's go and ask a question. Yeah, so let's ask this question to Claude. What is our company's refund policy? Yeah, so as expected, it will not be able to tell you that. It is saying I don't have access to company's internal document or policies. Okay, so someone will say that I can upload the document from here and I'll get the answer as expected. Okay, that is right. But what if the document is very huge? So in that case, we will hit the limitation of token size, or also as the tokens will be very huge, this will not be an optimal solution. This will increase our cost. So that is the whole point to introduce the concept called RAG, that is Retrieval Augmented Generation. In today's video, we will go over the RAG pipeline visually. We'll go deeper in each step like chunking, embedding, then storing it in vector databases, then retrieving by using cosine similarities, and generating the output by calling LLM. So all these steps we will go one by one, and I'll explain all these steps, what things are happening behind the scene visually. Yes, so let's get started with the rack pipeline. First of all, we will understand what is the outcome of building this rack pipeline. We are building this rack pipeline so that we will be able to chat with our internal documents. Okay, so for example, here this is our internal data. This is very huge data, consider like that. But for this understanding point of view, we have taken some short amount of data, small amount of data out of this huge data. Okay, so this is our data on which we want to ask questions. Okay, so how RAG works actually is, it is having two stages. So in first stage we do indexing. Okay, so whatever whole internal data which we are having, for this example, this is our internal data. So what we will do is, in first stage we will do indexing of that data. Basically we will chunk that data in smaller chunks. For each chunk we do embedding, and after that we will store that data in the vector database. This is the first step. Okay, so chunking, embedding, and storing, this is the indexing stage, and this happens only once. Okay, most of the times it happens only once: chunking, embedding, and storing. And second stage is retrieval. So this stage happens when user asks any question about this data. Okay, so when we index this data and store it in vector db, then user can ask any question about this data to our system which we are building through this, and it will be able to answer based on this information. Now we will go into each step visually and understand what is happening behind the scene. First stage is chunking, where we will divide the whole text into multiple chunks. So here each line equal to one chunk. So very simple chunking strategy. So for each chunk we want to generate embeddings. Okay. So what is embedding? Here we will understand actually. Embedding 9 sentences. So here 9 chunks are there. Per each chunk we will generate embedding. So what exactly embedding means? So embedding means mathematical representation of our language, our data. Okay, so here we are seeing, for this sentence is consistent hashing distributes load across servers. Okay, for this particular sentence we converted that into one vector of 768 dimension. So basically this is an array with 768 value. So each value represent some aspect of language. Okay, For example, uh, we want to represent apple, then apple can be represented as like multiple aspect can be redness, then size, then eatable. So these can be multiple aspect of the language, and each based on that particular object we will get values for those aspects. So based on that, for this sentence we got 768 values. Okay, out of these 768 values, here for representation perspective we are showing 20 values. Okay, so there are various embedding models available out there. So those models can be used to convert our language into the numbers. Okay, so how these embeddings are related to each other. Okay, so you will understand that here actually. So this is a 768 dimensional sentence, basically vector. So for representation perspective we reduce that 768 dimension to two dimensions. So here you can see that like relative, like the sentences which are related to each other are coming closer to each other. So here you can, if you are able to see that, so there are multiple groups which are created over here. If we go actual sentences, so you can see consistent hashing distributes load across servers. So this is something related to load balancer or distributed system. Hash ring assign nodes to position, so this is also related to distributed system. This load balancing related to distributed system. This sql, no sql, this database. So these three sentences are related to database. And what is this? The weather today is sunny. So this is some general thing actually. So how this embeddings looks like in 2D graphs are like this. uh, so yeah, so the here general information is coming over here, where something related to distributed system is coming over here, and related to sql database and database sharding. So these things are coming over here. So if you see over here, if you observe one thing, so sql related thing, sql, no sql, so these are very close to each other. And database sharding splits data horizontally. So if you see here, this is somewhere between sql and your distributed system. If you see the sentence database sharding, so this has some meaning specific to distributed system also. So it's like away from your sql database, and it's bit closer to this like sentences related to distributed system. So that's how these whole sentences are grouped together based on the embeddings, based on their meanings actually. So that's how we do embeddings for our sentences. So whatever you add, let's say if you add something to this, I'll add something like rate limiter is very important thing in distributed systems. So if I do that, let's say what is happening, embedding 10 sentences, naming clusters with Gemini. Okay, so yeah, so see, if you see this rate, this new entry which we did, like rate limiter is very important thing in distributed system. If you see this, so its vector is in a such a way that it came closer to this load balancing, this hash ring. So things specific to distributed system are there. So there we got this limiter related entry. So that's how this mathematics is applied, and it understands the relevance between multiple sentences. If we add something like I'll add one more thing. I don't like to eat pizza. So I'll say generate embedding again. So embedding is mathematical representation of your sentence. It's generating. Yeah, it's generated. So I don't like to eat pizza is coming near to daily observations. So from that you can understand like how these mathematical numbers are uh, making sure that relevant information should come together. Okay, so that is whole point of having embeddings. Okay, once these embeddings are generated, we will store them into the vector database. So that is the end of our stage one, that is indexing. Okay, chunking, embedding, and then store. So this is part of indexing stage. Then we starts with the retrieval stage, where we will search for a query, like we can ask any question for example, and then um, this pipeline will do cosine similarity between the embeddings of this query and the query embeddings which are stored into the vector database, and compare that and find the similarity, and based on that it finds the score. So now I'll say I'll ask some question. What do you like to eat? So this is my question I'm sending. Okay, based on our cosine similarity, it has generated the scores. Okay, so by the score, rank 1 goes to this: I enjoy eating pasta for dinner. So my question was, what do you like to eat? Okay, so first point is this. Second is, I don't like to eat pizza. So based on the similarity, the score is generated. Okay, so for rank 1 the score is 0.7107. So we got the relevant information for the query which we have asked, right? So how this is being done? It is done by using the cosine similarity. So let's look at how cosine similarity also work. So vector a is for example our query, and vector b is one of the entry in the vector database. Okay, so this is the vector for our query for example. So for that actually this will be having 768 dimensions. Okay, but here for understanding perspective we will show it as 2 dimension only. So let's see how this angle changes based on the values we change. Okay, if I reduce this x in vector a, so see what is happening. Okay, if I increase this y of vector a, then these two lines are getting closer. So basically, the angle between them is reducing. So see, if I am moving this vector a's y value towards this vector b y value, then this angle is reducing. As soon as I again changes the y value of vector a away from y value of vector b, then angle increases. So this is how it actually works. Less angle means it's more similar. So that's how it works. And the formula for this is mathematical. So if you are interested, you can look at this, like dot product of a and b divided by the magnitude of a multiplied by magnitude of b. So that's how it works. So basically the thing is similarity uh, score is find by using the cosine similarity method. Okay, we saw that the based on the rank, this I enjoy eating pasta for dinner. So this is the uh, text which we got from the database. So next stage, what is the next stage is that we will see in the full rack pipeline. So I'll again put the same question: what do you like to eat? Yeah, I enjoy eating pasta for dinner. Okay, so we what we did is, this is the whole rack pipeline. We will go one by one. I asked a question to it. Okay, this rack system. Okay, what it did is, it converted that query to 768 dimensions. These are the first 10 dimension of this 768. Okay, after that what it did is, it calculate the cosine similarity between this vector and the vectors stored into the database. So in database we have stored vectors for all these 10 entries. Okay, out of this, the first one, I enjoy eating pasta for dinner. So this is very similar to the question which we have asked, so that's why we got the highest number over here. Okay, are you able to understand this? Okay, out of this we will retrieve top three chunks. So this we will have to do by doing trial and error, like how many works best for us, and based on that we can take up. So these three chunks we took from our vector database, like I enjoy eating pasta for dinner, I don't like to eat pizza, the weather today is sunny and warm. So this is like less relevant, so that's why its score is also lesser. Okay, so with this data which we retrieved from the vector database, with that we will create one prompt for our actual LLM. Okay, so with for LLM we will create a prompt like, you are a helpful assistant, answer the question using only the context below. If answer is not in the context, say I don't know. So this is the prompt which we are passing to it. And what is the context is, the context is the data which we retrieved from our vector database. So I enjoy eating pasta for dinner, I don't like to eat pizza, and this thing. Okay, this is the question which we ask to it. So, and I also given like, what do you like to eat, as a question. So in answer which we are getting is, I enjoy eating pasta for dinner. So this is the power of RAG. So even if that LLM doesn't know what we eat or our personal information per se, based on the context which we provided to it, it is able to find out this answer. So if we don't have RAG in place, so if we just ask this question to LLM, what do you like to eat, so it will not be able to understand what I am asking. So it's, you can see its answer as a LLM, I don't have enough information to tell what I eat, I don't eat anything. So that kind of thing. So that's how RAG is very helpful to answer our questions which are related to our internal data. If you feel this video has done some value addition to you, then feel free to like this video and share with your friends and family.